This use of fraction bars is just so important for kids. They really need to see the size of these fractions. So here's a set of fraction bars that begins with one whole, which is labeled as 1 out of 1. And then it goes halves, thirds, fourths, fifths, sixths, eighths, and tenths. And there are twelfths also, but I stuck with these first sets of fractions just to talk about tonight. So the good thing about these is they include the decimal equivalent to the fraction and the percentage. So kids can start to see those relationships right away and understand how they're visually represented by the same part of the whole unit. 1 out of 1 is the whole 1 unit. And if you recognize uni as a prefix, you know it means 1, like a unicycle or a uniform, right? These are all things that 1 has to do with. So the first thing you do with your child is you ask them to look for patterns. What do you notice? What do you wonder? Hopefully they'll wonder, well, why do the biggest numbers have the smallest size associated with them? Why is 1/10 so much smaller than 1/2? When everybody knows that when you have 10 of something, it's more than 2 of something. So kids should begin to wonder why it's like reverse with fractions. And this is a great thing to think about because the number, the denominator, represents the number of pieces it takes to make one whole. To make one whole unit. So therefore it makes sense that 1/10 is a smaller amount and 1/2 is a larger, because that means it only takes 2 of these pieces to make the same one whole as it takes 10 of those tenths. So that's the first thing you want the kids to think about. And then you want them to start representing and seeing equivalent fractions. This idea of equivalency is really important. So ask your child, what is equal to 1/2? What sort of piece sizes do you see that when put together they equal 1/2? And they might take 1/3 at first and say, well, it doesn't fit, but I wonder if something else can fit in there. And they might take like a 1/5 and say, well, does that work? Is that the right size? And you'd say, no, it doesn't quite work. Sorry, try again. And they say, well, 1/5 was too big, so I'm just going to try 1/6, the next smaller size. And then they can see that that works. That's actually very advanced for kids to think about. Why does 1/6 plus 1/3 equal 1/2? Doesn't really seem to make a lot of sense until kids can maybe think and see the pattern that everything in this diagram can be represented by 6. Like 1/3 is equivalent to 2/6. And then they can see, or they could even cover it up with the other 3/6. They can see that 1/2 is the same thing as 3/6. Now this right here, this is very powerful math that a lot of middle schoolers really struggle with. Or it would take them a long time to do it because there's so many steps involved with traditional methods of showing fractions. But if a kid can start doing this when they're 5, 6, 7 years old, then eventually they can do it in their heads and they won't need to do all the complicated algorithms that don't make a lot of sense. So one more time, just if you take a half, and kids should be able to see that fourths are equivalent. And the beauty of the half, fourths, eighths thing is that now they can see that when you double the number in the denominator, it makes the piece half the size of the other piece. So 1/2 is equivalent to 2/4, which is equivalent to 4/8. Please like and follow Super Teacher Guy, my YouTube channel, on TikTok or Instagram, and we will delve much more deeply into fractions and the use of fraction bars as an awesome visual model for your kid.